Hello, my friends. We're here. This is the NOLA Mathman here for another fun math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to do trigonometric functions involving circular functions. The concept we're looking at is trigonometric functions. The skill we're looking at is circular functions within trig functions. So with no further ado, let's get started with our lesson today. So in this problem, we're looking at the terminal side of angle A and standard position intersects. We're going to find basically cosine theta and sine theta. So we're going to do number one. Cosine theta is equal to basically x and y. That's basically, so we first start by saying the point xy is equal to the point of cosine theta and sine theta. So cosine theta corresponds to x, sine theta corresponds to y. Since the first coordinate is cosine theta, we will say the cosine theta is -1/2. The y coordinate is sine, so sine theta is square root of 3/2. Very simple thing. I was being too verbose, but it's pretty straightforward. So in this problem, we have 0.8 and 0.6. And again, we write that xy, that point, corresponds to cosine theta, sine theta. So using the coordinates xy, we know that cosine theta is going to equal, in fact, I labeled in this problem x and y. So cosine theta is 0.8 and sine theta is 0.6. And so that's basically all they're asking you to give. And that's it. We can now go to another type of problem. We're now doing number 4. We have 0.0 -1, and again, xy will correspond once again to cosine theta, sine theta, and that's what you want to write. You want to get in the habit of writing the same formula over and over. And so since cosine theta is x, cosine theta in this problem is 0, and sine theta is going to equal what? Y, which is -1. And so that's what's going to show up here on the screen. And we're done with that part. So it's pretty self-explanatory. This is a very easy concept. You just memorize it and you correspond those coordinates to one another. So now we'll do number 6. We have square root of 3/2 is x. 1/2 is y. We'll correspond that again to cosine theta and sine theta. So again, the cosine theta is x, which is going to be the square root of 3/2. And the sine theta will be y, which is 1/2. And so we go right. So we're done with that. So that's a pretty easy concept. You just correspond x and y to cosine theta, sine theta, and just label, instead of x and y, we label them cosine theta, sine theta. So now we're going to determine the period of each relation of function. Now, period is when you go through one cycle. So it's basically when you go back to where the starting point is. So in this figure, you can find the period at any point. So I start at the top where the highest vertical point is like at the top of a triangle, and so you want to do the next one. One of them is at y, theta is 1, and then the other one, it repeats again at 5. So one cycle is from basically 1 to 5. So our period will be the difference between 5 and 1. And since we know 5 minus 1 is 4, the period in this particular problem will be 4. So it takes a cycle of 4 theta to repeat the particular relation or function that we're looking at in this problem. So, and if you would have did at any other point that repeats, you would have that same period of 4. So in this, we have a different figure that looks more like a rectangular type thing. So we start where it goes up here. So I start my theta at the point between 0 and pi, and it repeats the cycle at the point halfway between 2 pi and 3 pi. So that space between those two things are basically going to give us one period. I did another thing that's easier because it's already labeled. So instead of going from that, we went from pi to 3 pi, but it's the same period. And since it's already labeled on the graph, I changed it to NOLA MATHMAN in order to make it easier to determine the difference. So the period in this problem, again, where the cycle repeats, it will be 3 pi subtracted pi. And so the period in this particular function is going to equal 2 pi. And so that's the problem that we have here. So the answer is 2 pi. So again, it's not a hard concept. You just want to pick 2 points on the function where one whole cycle is completed, and you find the difference in that. So now we're going to use our unit circle to estimate the exact values of each expression given. And so I give you this unit circle to help guide you to the values you want to get. So again, we know that xy is equal to cosine theta sine theta. We looked at those set of problems in the first group of problems we were looking at. And so let's see which problem the NOLA MATHMAN wants us to do first. So we're going to do cosine of 7 pi over 4. So we look at our figure and we want to see where 7 pi over 4. I circle it here, the NOLA MATHMAN, and so you see those values. The first value is cosine. So the cosine is the square root of 2 over 2, because x in that problem is the square root of 2 over 2. And so your value will be for cosine of 7 pi over 4 is square root of 2 over 2. So it's pretty easy. You just locate the point on the unit circle, figure out what the x and y. If it's cosine, it's the x coordinate. And if it's sine, it's the y coordinate. So next one we're going to do is negative 30 degrees. So in that one, we're rotating instead of going counterclockwise. When it's negative, you go clockwise. So we're going to go negative, which if you go 30 degrees, that equals the sine of 330 degrees. That's the value we're looking for. So since we're looking for the y coordinate, that is negative 1/2. So the sine of negative 30 degrees is equal to negative 1/2, because that is the y coordinate, which corresponds to sine theta. So we're going with that one. So these are pretty easy to do. You just, locate the correct position where your rotation is on the circular function, and then you pick out the y or x depending on what's given or what's asking. If it's sine, that's y. If it's cosine, it's z. So here we have sine of negative 2 pi over 3. Now this one's given in radians. Sometimes it's given in angles, sometimes it's given in radians. So again, we rotate clockwise. Sine of negative 2 pi over 3 is the same value as sine 4 pi over 3. So we're going to go to 4 pi over 3. We circle it on the unit circle, as you can see in yellow. And y is the sine, so our sine of negative 2 pi over 3 is the y, which is equal to negative square root of 3 over 2, which is going to pop up here in a sec. And so that's our answer. So let's see what we do next. So we've done a variety of problems here. In fact, what NOLA MATHMAN here shows you rotation when you go in a negative direction. So that's what you see there on the screen. So let's see what we do next. We'll do number 13, cosine of 600 degrees. So now we're doing more than one rotation, because a normal rotation is 360 degrees. So you want to find the reference angle that corresponds to 600 degrees when you rotate it. That will be one rotation. And so you can see here, we break it down. Cosine of 600 degrees is a cosine of 240 plus 360. So cosine of 600 degrees will be equal to the cosine of 240 degrees. So now we look on our unit circle, we circle our value in red, and so cosine is the x-coordinate, so that value is -1/2. So the cosine of 600 degrees is equal to -1/2 because it's the same as the value of cosine of 240 degrees. That's a concept of reference angles, which the NOLA Mathman had covered on a different video. So let's see where we at now. So you can do a variety of different problems, like I said, using angles or radian. Let's see what this is. This is a radian problem. 16 -11 pi over 4. Again, we have to go clockwise. So we're going to go clockwise and we're going to find a reference angle that corresponds to. So that corresponds to -2 pi, because we have to go one rotation around, and then we add that to -3 pi over 4. So cosine of -11 pi over 4 is equal to the cosine of -3 pi over 4. So now we want to look on our unit circle, we go clockwise, we want to see what positive corresponds to that value. And the NOLA Mathman has calculated that is 5 pi over 4. That's equal to -3 pi. We circle that value, cosine is x, and so the cosine of -11 pi over 4 is going to equal to negative square root of 2 over 2, which is the x value. And so we circle that answer as the NOLA Mathman has instructed us to do. So what do we do next here? So we're doing a variety of different problems. Some are positive values, some are negative, some are angles, some are radian. You want to get comfortable with doing every type of problem, and that's why the NOLA Mathman here is going through a variety of different ones. This time we're doing another radian, cosine of -10 pi over 3. So again, we know that we're going in a clockwise direction. We're going to rotate. We want to see what the reference angle is. This should be -6 pi over 3, which is -2 pi. That's one rotation. We add that -4 pi over 3. So cosine of -10 pi over 3 is equal to the cosine of -4 pi over 3, since that's its reference angle. And so now, using the rotation, we want to see what positive angle corresponds to -4 pi over 3, which is 2 pi over 3. We go to our unit circle. We circle that value in green. And since it's cosine, we're looking for x. And so the value of the cosine of -10 pi over 3 will be -1/2. And that will be our answer. So cosine, that should pop up here in a second. That's what the NOLA Mathman is saying. That is equal to -1/2. So we circle our final answer, so we don't get confused with the reference angles and other things that may come up. So, next here. So, we have any more we want? Oh, we have a word problem. That's neat. So it says a Ferris wheel with a diameter of 100 feet completes 2.5 revolutions per minute. What is the period of the function that describes the height on the outside edge of the Ferris wheel as a function of time? So we know the period is the time it takes. This is what the NOLA man is giving you some information to complete one revolution. That's what the period is equal to. That's the definition of period. So in order for us to do that in this problem, we know the diameter is 100 feet. We're going to use that information. We know that it completes 2.5 revolutions per minute. So in order for us to get the period, I'm sure we're going to do some sort of calculation involving 100 feet and 2.5 revolutions per minute. So I would think you would take the minutes, which is 60 seconds, and you're going to divide it by 2.5, revolutions. That's what the period is equal to. And when you divide that, you should get the answer for the period in this problem. And that will give us a value of 24 seconds. And that's our answer for the period that it takes for this particular function. So we have done a word problem looking at the whole circular function. The NOLA MATHMAN has circled our final answer, which is 24 seconds. And again, the more you do word problems, it may be a little confusing, but you keep practicing. There are examples that you can check for doing period and revolutions. And so the more you do, the more comfortable you'll get. But we've covered a lot of different aspects of circular functions. It's important to understand the degrees and radian aspect of it. And so again, the NOLA MATHMAN is finished with another adventure. We've gone over the concept of circular functions in regards to trigonometry. And so until we meet again for another math adventure, this is the NOLA MATHMAN signing off. Have a blessed and prosperous day.